Hi everyone, it's nice to meet you again. I am Dodi Sudiana and finally, this is our last meeting in our basic computer course for this semester. Looking forward for you to meet you again in another course, of course. But for now, hopefully you are still in high spirit and have a fantastic time with your family during your learn from home. And what will be taught today is to introduce you a fundamental or basic of structures and unions, which is it's quite a new uh, topic in our course, and enjoy the course. Well, actually, structures. Well, this is some kind of a new term, right? We've already learned about array, learned about pointers, and another topics related with C programming in basics. But today, I will introduce you to new facility or new form of data structure in programming. And how to define a structure? Actually, we start first by knowing that sometimes this structure is also referred as aggregates in C standard. And it's a collection, actually, a collection of variables of different types under a single name, right? So the keyword is different types and a single name. So structures may contain variables of many different data types. So in contrast to arrays, which contains only one element of the same data type, structure can contains so many types, right? So we are looking to a new kind or format of data processing in C programming. Also in file processing, which is not covered in our syllabus, structures are commonly used to define records, yeah, to define the data to be stored in files. For these topics, you can learn in details book in chapter 11. So the pointers and structures also facilitate the formation of more complex data structures like in linked lists, queues, stacks, or trees. So for this kind of structure, you can also learn in chapter 12, which is unfortunately is not covered in our syllabus for this semester. And also in the second part of the course today, we'll also discuss about unions later on. Okay, so structures are derived data types. So in the syntax of the structure, they constructed using objects or other types. So you start by declaring the data structure in a struct comment and followed by structure name. Okay, so we construct this structure name as various data. You can select any data type for each member. For example, you set in this example, you see employee as a structure, and you can see that the first data is a name. It is a character of 50 digits, followed by employer number, integer, and salary in float formats. So all the structure begin with curl brackets and also ended with this in the close curl brackets. And also you can add some variable names to define as well as the structure composition, and ended by a semicolon in the ending line. Okay, so finally you can see that structure can contains members, right? Structure members can be defined in any kind of variables, which is also introduced before. You can use array, you can use pointers, you can use float, and any kind of data. Okay, so please take a look of the structure here, that it is unique format. And to access the members of the structure, you can see there are two types. The first one is using the member operator or dot operator. In this case, you can mention the structure variable name. for example, name, and followed by a dot and the member name. Okay, sorry, structure variable name is employee, so followed by a dot and member name. So you can access the name of an employee by using the structure name and member names separated by dot symbols or member operator. The second way is using some kind of arrow, but actually this is a structure pointer operator. Will be discussed later on when we deals with also another topic related with the structure usage in C. Okay, so let's move on to an example, how to declare or define a structure and how to use it in a simple program. Here we can see that the structure is named distance here, and it contains two variables. The first one is feet, it is an integer one, and the second one is inch, it's a float type data. So still remember that in our measurements or in our systems in international measurements, there are two units which is already known. The first one is the imperial or British units, which based on foot or feet and inch, and the other one is a metric system, which is based on meters, kilometers, etc. So to convert a metric unit or a British unit to metric unit, please remember that 1 foot is about 30.80, oh sorry, 30.48 centimeters. Okay, so 1 inch is about 2.54 centimeters. So, well, if you have a 30 centimeters of ruler, and you can see that it's also has a length of 1 foot, right? Because it has 30 centimeters in scale and also an inch in the other side of the ruler, and you can see there is a quite familiar unit also. So in this program, you want to add two distances, the first one and the second one, in British unit, which is expressed by inputting the feet length or the feet distance and the inch one. Each of them has a different format. Feet are usually integer, and for inches, usually using floating variables. So to make it much easier for you, I will show you the program in CDEF compiler. See that uh, the structure is a global variable, which means that all the structures should be acknowledged throughout the program, so the whole program can recognize it. So it is a global one. So it was firstly mentioned here after defining the library, and each member should be defined and ended by semicolons here. And you can also define specific variables which has this structure. So in this case, you have this one, this one, this two, and sum. So you want to add this one and this two and express it in sum and display it in the screen. Okay, the first one is to input the distance in feet and inch respectively using scanf, and the second distance also the same format. So you have 4 variables. So if you want to sum distance in British unit, you should add the feet components and followed by inch components. So in this case, sum dot feet, meaning that the member of sum related with feet distance is addition of those the distances, and the inch part of the sum is also the addition of the two distances in each in inch. Okay, so in this regulation in British unit, as I mentioned before, that 1 foot is equal to 12 inches. So if the sum of the inches is exceeds 12, then you can add the feet into by 1. So plus plus sum dot fit, it is an increment by 1 of the changing 12 inches into 1 feet, and the rest is the part of the inches, right? So the sum inches should be subtracted by 12 to make it to make sure that the addition is accurate. Okay. So lastly, you print the distance as feet and inch components, and after that you can end the program. If you compile the program and then you input some data using your keyboard, for example, the first distance you fill the feet distance is 10 feet, and the inches is maybe 8.78, and the second distance is maybe 5 feet, and you add some inches, and you got the results here: 16 feet and 3.76 inches, right? So this addition is a good accurate result. As you can see that the inches part is exceed 12, so it should be subtracted by 12, and the rest of the 12 inches should be converted to 1 feet, 1 foot, I mean. So it increase the number or the total of feet in this of the distance. Okay. All right. So let's move on to another definition using a new command. In this case, you are using a type def, right? Type def is a new, is a mechanism for creating synonyms actually, for naming or for referring your data into a structure, or you can just say that the type def is an alias, is another name for your structure. So if you write the struct and structure names and variable names to declare a structure, it isn't quite familiar, right? It's quite long, uh, long declaration and long variables. So to take some considerable amounts of development time, and also to make your program more portable, more readable, and maintainable. So you developers, including you of course, can use or generally use typedef to name the structures as a whole, and your program will become shorter, right? So you can revert variable names that can be attached to a structure, and by type def you are actually creating a synonym for the structure. Okay, so for example, you firstly mentioned the type def and the structure and the name of the structure. In this case, complex is the name, and it defines contains of one integer. Imaginary image is the variable names, and one real or float variable, we call it real, and you mentioned it as a com, type def com. So type def structure name and com, the name of the alias or the other name is a common common practice. So by define comp as an alias to the structure of complex, your program will be very handy. You can see just mention comp as the type of the structure and the variable names represent the structure itself. Okay, so in this case that you have two variables, comp1 and comp2, which has the exact structure as defined in complex here, without mentioning the struct complex here in your program, right? Because you already define it, the structure as comp. Okay, so it is quite useful when your program is more complex. So in this case, you can also expand your structure using the nested structure. So earlier, you already learned about how to make, looping in nested structure or nested blocks. So looping in a loop, and also another structure in a structure is quite common also. So you can make your program by constructing your structures inside another structures in C programming. Okay. So as previously you learned that the complex structure is contain imaginary value and real values. You can also use this complex structure in another structure called number. So just mention the structure complex here and mention the variable names. So you have uh, two members in number structure and one member of the number here, the structure of number here has another two members, right? So actually by doing so, by defining this structure, you have actually three variables, right? The first one is the complex variables, contain two variables inside it, and the other one is the real variable, which is also integer. Okay, and you can define all variables you need to represent this number. Okay, so if you want to access the imaginary value, for example, this the first the first member of the first structure complex. So if you want to access this imaginary value for number 2, for example, here, number 2 is already defined here, and you want to use the dot operator to express it or to access it, just use this statement, right? Num2, this is the variable name of number structure, yeah. It has a structure of number. So in this case, number of complex value, because you want to access this one, right? So you also call the comp, because the complex structure is represented by comp. So they are the second variable. And finally, you can access the third variable, which is an image value, by separated it with a dot operator. So it's quite useful when you are dealing with some complex data to make this kind of nested structuring system. Okay, so now we are going to have a look about the pointers and how it used in a structure. So as well as another usage in defining your variables in more complex one. Structures also can be created and accessed by using pointers. Yeah. So you can access it by its members by defining all the values here. But also you can access it by defining the address. Okay. So the address is also take a role how to refer your data by showing the location or the address using a pointer. So a pointer variable of a structure can be created as well as ordinary variable. For example, you have the structure name here. Define it. It has some members inside it, and in the main program you can struct name. Define this structure using pointer variable. So a pointer variable PTR here refer to the address of the location of the position of the data in the memory, and in those locations there are located each data. Okay, so member 1, member 3, etc. here it can be accessed using the address of the structure itself. So the first address of the structure can show also the data by you refer it to a pointer. Okay, so when you also deals with the pointer, as you already learned before, that the structure members also can be accessed using referencing pointer to another address to access the memory by using a call by reference. Or you can also using a dynamic memory allocation using malloc or calloc. You already learned about it, right? So remember that. I hope so. So you can combine the structure, the pointers, and also the dynamic memory allocations in one applications in your program. Okay, so let's see an example here. Okay, so in this example, you can see that this is a structure of a person which contains two members, two fields, two data, age in integer format and also the weight in float format. Okay, so there is a structure called person, and the structure the structure of person uh, defined for two variables actually. The first one is the pointer. You can see the asterisk sign here, and the other one is another, ordinary variable, person one. Okay, so this is contains the value, and person pointer contains the address. Okay. Okay, how to relate these two kinds of data? Yes, by simple assignment like this, person pointer equal to address of person one. Okay, so each of those pointers and the data is related each other, right? By referencing pointer to memory address of person one, then person one data can be accessed using the address of what recorded by the person pointer, right? So, okay, let's see the example in the compiler to make it sure that the program is running well. So, okay, so let's start with defining the structure of person. Contains two variables here, age and weight. And after that, you see that the two variables are defined here, static memory allocation. Okay, and relate the pointers with the data by this statement. And after that, you can enter the age. There are two ways, as mentioned before, that you can also use the dot operators, yeah, to refer a member of a pointer, the structure, which is represented by a pointer. And also you can also using the, structure pointer operator. It's an arrow sign here. Okay. So arrow sign here showing you the same function or the same usage as the dot operator, but you can see the difference is the how to write the pointer's name. In the first way, using dot operator, you can see that you mention the name of the whole pointers here, person pointer, star person pointer here as a whole. And after that, you can see that, sorry for this disturbance, there are so kids outside. I think I close my window. Okay, the first way is to mention the whole pointer's name inside a bracket right here. And followed by the dot operator and the member. Okay, the other one is using the structure pointer operator, which is shown here. So so these two ways can be used, and you can choose which one you want to, or you want to use the most preferable one, right? In my opinion, this using structure pointer operator is more useful and more practical in terms that they are not so complicated as the dot operator. But yeah, you can decide which one suitable for you. Okay. So entering the age in integer format and the weight in float format, and display the results in years and kilograms in this case, and see that the pointer can be used to show your data, okay, by using this structure pointer operator or using the dot operator here. Okay, so let's try the first method using the structure pointer operator. You can ignore this kind of warning. Yeah, it's no problem for you because it is only just to show you that the compiler is ignoring your declaration because it is already enabled the type def, right? Okay, so you can see that there are no problem. So you can enter the first one is age and the weight here in kilograms, okay, and display the results. Okay, so after inputting all the data, you can see that the result is quite uh, accurate. You got the right result, and you can see that the second way is also working. Okay, let's comment this one. Okay, okay, right, okay. So I think it's clear that by referencing a pointer to to access your data uh, using static one, meaning that only you are you are using ordinary pointers without any memory allocation, which is we'll learn later on in the next slides. So you can see that pointer works as well as in non-structured data format. So you can make useful of it, and you can make it a very flexible one if you are using a pointer to do some calculation or some data processing in your program. Okay, so let's move on to the next slide. So we are showing you the using of dynamic memory allocation to access your structure member through pointers that already explained before. But before this, only a single data, right? It is static one. You're just only using one pointer to access your data. In this case, you want to make your program more flexible by you know entering some data, not only one. So the program will be started by as uh, as previous one. You define the structure, and don't forget that since the malloc, still remember malloc, right? Malloc syntax is just mention the pointer name and the case type of the pointer, and then using malloc instruction to reserve your memory allocation and the size of the size. Okay, it belongs to standard library.h, so don't forget to include this one beforehand, so your program will run smoothly. Okay, so in the main program, you same as previous example that you struct the person, yeah, and using a pointer for that, and the pointer is allocated some spaces in the memory using malloc instruction, but it depends on the number of person, right? So firstly, you input the number of person you want to entry, you want to process and you want to display after that, and you allocate it based on those size of struct person, right? So struct person here actually has a size, and it should be allocated uh, beforehand. It should be allocated beforehand, and the number here, right, decide how much the record or how much the structure should be, provided by the compiler. Okay, so the statement allocates the memory for n structure, meaning for the num structure with pointer PTR. Sorry, this is already mistakenly mentioned. The PTR pointing to base address. Okay, so the first address of the structure is located in this pointer. Okay, and after that you can shift the address of those structures by one, and you can see this is how to uh, print it and also to scan it, to input it by adding it or shifting it by one by one. Okay, starting from 0 to number -1, and it increased by 1. Each looping is executed, and you input it one by one. Okay, starting by name, the age, and the weight. Okay, and finally, after this input data is finished, you display the information using this kind of statement. Okay, so let's see the example in the compiler. uh, First one, uh, sorry, this one. First one, you don't forget to include the standard library first. After that, you define the the data structure, including name, which is a character of 30 digits or 30 letters, or 30 characters. And after that, you define the pointer here. Okay, using struct person pointer. If you want to use a type def, just add here type def struct person, and this is maybe man. Okay, to represent the person. Okay, so you just mention here man, and your program will run well. Okay, so after that you enter the number of person and using a variable of num, and after that you allocate the memory as mentioned before. The size is num times size of structure person. Yeah, you can also change the structure person here into man. Okay, and also you can exchange this one into man also. Okay, right, so I think the rest is just input the data one by one and then print the result. Okay, you can also use a \t to make it separated by type. Okay, for each data you want to show, and after that you can see the result. Okay, okay, number percent is maybe 3. Okay, so the first one is me, age, okay, and weight maybe, right? And second name is, okay, and 20 and 55 maybe, and the third one is maybe Rudy, it's only 18, and it has weight about 57. Okay, so the result is the data which is already entered previously is displayed in tab separated format like this, like a table. So you can see all the data is correct and nothing's wrong with the result, and you can see that the pointers and malloc and also the type def and also the structure is quite useful. Okay, so remember that if you want to uh, use some new command or new instruction, don't forget to remember which the library it related to. Yeah, in this case, the standard library is quite useful when you are working with dynamic memory allocation. In this case, you use the malloc instruction. Okay, I think it's quite clear for you to this example that's showing how to combine the memory allocation dynamically with the structure. Okay. All right. So the next one in our slides is related to how to use a function in a structure and how to send the data from main program to a function using structured data format. Okay, so in this case, we can see in this example, the first example is showing you how to pass by value from main program to a function using a structured data. Because you maybe still remember that you can use a function by passing the parameters by value or passing the parameters by reference. Okay, when you deals with the pointer, then you are using the pass by reference. When your deals only on values, just you pass the values to a function, right? So to pass a structure uh, to to functions, you can see that you can pass individual structure members. For example, you just send a name or role only, or pass the entire structure members, or using a pointers to refer your parameters to the address of the structure. Okay, so it's quite you know quite practical if you can use also not only just values but also address, because as you already learned before that using pointer in passing parameter or arguments in the function can give you flexibility, because the function can directly change the contents of your data in the function itself without any process of taking back and copying all the results to from functions to your variables in the main program. Okay. Okay. So in this case, you have a student as the structure name, contains two variables. They are name in 50 characters of data, and followed by role. This means that the student enrollment number in integer format. And you just have one function here, display the structure student of stu here. Yeah, because you only just send the variable of the content of the variable to the function and display it or print it in a very simple way. Okay, in the main program you have student start, meaning that stud is maybe a student. Yeah, stud here. Okay, and then after that you input the student name followed by student roll number, and after that you display stud here, the value of stud, by sending the variable of structure stud, which belongs to structure students, to stu. So stud will be copied to stu here because they have the same structure, and the function just print all the members, right? The name and also the student roll number. Okay. Okay, let's see the example in the compiler here. Okay, so because it's quite long, then you already learned about type def. I think you can also use type def here to make your program more simple. I called it the Syswa, and display the Syswa here. Just call it Syswa and start here. Okay. Okay. Now you are working with it. Student name, for example, my name, roll number 1, 2, 3, 4, 5, and that's it. Okay. The name and the roll number can be displayed correctly by using this kind of passing parameters stu start from main program and copy it to stu in the function, and you're already familiar with the type def. It is quite simple to represent the structure mentioned, because you have aliased it to Syswa here. Then just mention it as a you know alias or another name for struct student. Okay. Now you already learned about how to send the value here stud, because stud is already has its value of name and roll student roll number. Then if you send it to the function, then you send the value of those and copy it in the function. It copy it to stu, and you have those values printed in the function. Okay, right. So this is a very simple one. And the next one is how to make the function passed by reference. So let's see this example. Still remember with the British unit of distance, right? Feet and inch. In here, you also do the same way. You are uh, adding two distances and present it in feet and inch respectively. And the function is add here, and it has a struct distance of d1, d2, and the last one is a pointer called star d3. Okay, so the function is related with a pointer. So in this case, you pass your function using passing by reference. Okay, because you deals with pointers, you send the address of those data to the function. Okay. Okay, same as the previous example, just input the first feet and the first inch, followed by the second feet and second inch, and in the function you edit those two distances and represent it into the address of the third variable called this tree. Okay, and finally you print it the this tree in feet and inches respectively. Okay. So let's see the example here, because you don't see yet the function of add here, but in this program you can see all the whole program. Okay, again, you can use your alias here, and you can name it as jarak, and all the struct distance can be replaced by jarak. Okay, jarak d1, jarak d2, and jarak pointer d3. Okay, so make it you more familiar with the type def, how to declare it, how to use it in the program. Here is jarak also, right? Okay, and after that you change this structure distance into jarak. Okay, so you have those. Okay, the program is inputting all the distances in the main program, sending those values, this one and this two, to functions, and get the results presented in this tree by referring its address. So in this case, that D3 is already a pointer, so you just mention D3 followed by structure pointer of arrow here, showing the feed here. So D3 of feed is equal to D3 of feed. Because this is not the pointer, you can use the dot operator here, okay, because it's related with the value, okay, and also the inch part, okay, and as well as the previous example showing that if the D3 of inch is more than or equal to 12, then it should be increased by 12, and the feed part should be incremented by 1. Okay, right, so let's see the result. So for example, you input 10 feet and maybe 7.56 inches, and the second one is also 10 feet and it has 94 inches, and you have the result 21 feet and 4.50 inches. Okay, you see the result is correct, right? Because 7.56 inches add to 82.94 is more than 12 inches, right? Okay, so in this case that you already learned how to deals with passing structure to the functions using references, using the pointers, and you can deal with these operations further and elaborate it, and you can see that this is quite simple to mention or to define all of the members, because in this case that the structure is already the same for all of the three data here, D1, D2, and D3, and just make some, processing to represent it, the result, and send back the result to the main program. In this case, the printing is performed in the main program. Okay. All right. Let's see the slide. Here the second part of the example that we already seen in the compiler. Okay, let's move on to the second part of this course. It's called unions or union. Yeah, union means only one structure. Unions represents the various format. Like structure, a union is also a derived data type, so you can combine or you can uh, collect all the members of your data in the same way as structure is. But in this case, there is a little difference of union with the structure, because in union it shares the same storage space. Okay, so sometimes in your situation in a program, in a program stage, maybe you see that there are so many variables, right? But some variables may not be relevant, okay? But other variables are. So a union is, try to compact your space, instead of wasting storage for all the variables you are defined in the program, instead it doesn't mention or it doesn't use or just uh, ignore the irrelevant data, right? So in this case, that in union usage, please remember that uh, most of the data will be ignored except that one that you want really, or the last change data or the last access data, okay, because all of the rest will be ignored, okay. So in this case also, union can create some efficiency because the size of the structure is only based on the largest member, okay. Okay, let's see the example because it's quite not easy to understand, okay. Okay, so basically unions is similar to structure, okay. You already learned about structure, right? But in defining the union, I started by mention the union. For example, the variable name is car, and car has name of the car and the price, and you define three variables: car one, car two, and a one pointer car three. A pointer car three is can be relevant to the address of the structure of union card data here. And in this case also, like you already learned before, union card can be also used to define the car 1, car 2, and car 3 in the main program. So you can see the difference between these two assignments. The first one, you define it first time when you define the union. The second one, just union first defined, and after that, the variables in the main program. It's the same, okay? Okay, so in this case, working like structure, you can access each of the member data using those member name separated by dot operator here. Or if for pointer, you can using the structure pointer operator, the arrow sign here. Also, you can use, uh, dot operator by writing all the pointers name completely in brackets, and then you mention the member of it. Yeah, it works exactly the same way as structure. But the difference is when you, for example, in another example here, you have three variables in a union, and you have also the same variable for structure. So structure and union has the same, those have the same data, even the same name variable's name. It's no problem because all of those variables is a local one, so it won't be used when it is not necessary to be accessed. And each of those union, we call it a U job and S job, yeah, because it's related with the employee. And in the main program, you just print size of union and the size of structures in terms that size of, okay, size of U job of the union and size of the structure job. What is the difference between those two? Is the size of union has a less, size here, only 32, comparing to structure, which is 40. Where are those numbers come from? It comes from the size of each data defined here. So character name is 32, so it has 32 bytes, right? And also salary is a float, and worker number is also integer. It has 4 bytes each of them. So the structure record all the variables separately, but in union it combines all together and depends on the largest elements. In this case, the name. Why the name? Because it has 32 bytes, comparing to only 4 bytes for salary and worker number. Okay, so in this case that you have spare maybe eight bytes, yeah, 8 bytes less than the ordinary structure. But still remember, right? Only one of union members can be accessed at a time. Okay, it's different with the structure. You can access all of the members anytime because the data is located in separate locations in the memory, while in union it will be stored in the largest element of the data. Okay, the element space, the largest space of elements in the union, and the other members will contain garbage value, meaning that it will be discarded or will be an arbitrary values. Because in this case, remember that in in union, you are thinking about not all of the data uh, needed at a time. Okay, maybe you only need part of them, some of them, and the rest will be ignored or won't be used. So in this case, the union will be more efficient than structure. Okay. Okay, let's see this example in a program, right? Okay. See, this is a union, you job, okay? And this is struct job, okay? And as job is the variable's name. And we want to print the size. Of course, we have already seen the result, 32 and 840. Okay, but how about if we want to enter the data and using union, yeah, enter the data and see the result of those entries, yeah, when you want to display it. Let's see this example. Yeah, there are names of 32 and followed by salary and worker number, and then you input all the data here into job one, okay, and display the result, the name, the salary, and the worker number. Okay, let's see the result. For example, name is mine, salary maybe something like this, and this is my worker number. Okay, see, there are three variables, right? Only the last access data will valid here, in this case 1 2 3 4 5, and the previous one will be ignored, right? Because principally in a union there are only one space, right? Even though you have 10 members of data in your union, they shared in one space, in one location. So if you try to access all of them or more than one amongst those members, then don't use, I repeat, don't use union, okay? Because it will be ignored. Yeah, you get, this is strange, values, right? And invalid one, okay? The valid one is the last entered data, in this case the worker number, okay? So in this case, I think it's quite clear for you that union is only has a limitation that only access one data at a time. But in some case, maybe you can also elaborate a condition that it is still relevant that you use the union instead of structure. Okay, right. I think this is the end of our course or our explanation about structure and union. Here the another example here. Hillary salary is like this, sorry, and it displayed like this, right? So there are a possibility, not a possibility, but that will be no valid values when you deals with a union if you want to display it more than one data. So the last one will be valid. Okay, right. And union also works in functions like same as structure. So I won't repeat it again to explain it to you, but uh, it works exactly the same mechanism, the same way with a structure. And to conclude our course today, so we learned so far about the structure of a data, which is has the opportunity for you to expand your data variability. You can collect some relevant data in one record and one structure, and use it for your analysis. And you can also check the how it works with the a function, and how also to make use of a type def, which is quite practical to alias or to shorten your structure name or your union name. And also you deals with the how to send some parameters from the main program to the functions using a data structure. Either you send it by value or you send it a pointer by referring to a certain address using call by reference. And also finally you can also see the difference between union and structure in terms of data access. Okay, so let's continue. As usual, I will give you some exercise and a challenge to you to do at home. So in the exercise, you just have to write a program that computes meaning to add and multiply two complex numbers. Okay, you see that this is quite useful when you analyze the data in a complex format. And it is quite useful also in electrical engineering, in terms that some of analysis needs these representations. Okay, so a complex number, as you know, that it consists two parts, yeah, the real and imaginary part. So you can make a structure like this. Okay, and between real value and imaginary value, you should represent it using plus real value plus j imaginary value. So don't forget, when you print it, you don't you include those writing convention for complex numbers. And to add or to you know uh, operate two complex numbers, you just deals with real part addition followed by imaginary additions. Okay, so this is quite a simple one. And to multiply it, just because the complex multiplication will result in also complex variables or complex values. Don't forget to use this formula, because real part will be multiplied each other, and minus of imaginary part, because two imaginary values will have a negative values when multiplied each other, and followed by this complex part. Okay, right. I think it's a quite useful exercise for you to to make your skills using the, the structure format can be improved, and your programming skill in general will be also better and better. You do a lot of exercises related with this kind of problem. Okay, so the challenge is also related with the structure also. So you want to you have to write a program that calculates the GPA. GPA means the, index prestasi in bahasa, and prints out the list of courses. So there are several courses that should be recorded in your program. So that's why you have to use a structure here, and showing his or her GPA, okay, based on the scores, based on the mark of the students. Okay, so in this program also you also have to use a structure format followed by malloc, because there are several data. For example, maybe there are 10 students to analyze the GPAs, and also the pointer to make functions of those program. Okay, so the input is a student's name, number of courses using dynamic memory allocation using malloc, right? So remember that. And input is courses using a function called by reference, because the data should be very dynamic, and it should be changed every time you input the the data, the course ID, the credit point, and also the mark. Okay, so also the mark showing you the corresponding weight. For example, A is corresponds to weight of 4, B is 3, etc. Okay, and also these categories. Okay, so because you have to calculate the gross GPA, which calculates all the courses, and also the net, which only count or only calculated the past courses. Okay, so make some variety in your data by entering different marks and also different credit points, and also you can see show the result, whether the student is excellent or just average or below standard, based on those cases. Okay, so make it some cases. Okay, of the students record of student scores. Yeah. Right, I think it's time for me to finish our course today. I hope you're still in very good health and keep highly motivated and have high spirit to finish your courses this semester. Even this still have the you learn still have to you know uh, has some limitation because you have to study from your home. And I think it's nice to meet you all virtually, and see you next time. Have a nice moments with your other courses, and hopefully we can meet you again in another course or in another opportunity in the future. Okay, I think it's time to say goodbye. Thank you very much. See you next time. Bye bye.